Okay, so we were speaking on the lungfish, sorry, what do you call distribution of peripatus. Peripatus belong to phylum Onychophora, and it is represented only by a single genus, that is Peripatus, and it is divided into several subgenera. Okay, and it is the best example, that is lungfish distribution and Peripatus distribution. They are the best examples for discontinuous distribution. And members of this genus are distributed over the warmer parts of the world. In You can see in widely distributed areas like here you can see this region. Sorry. Okay, here you can see the Malayan region. Here it is the archipelago. Then you can see this. 1 minute. Okay, you have the Australia here. You have the South African region on this side, and you can see this part of America, and here you can see in India. So it is widely separated. Okay, and it has been found that the peripatus of different geographic regions forms several subgenera. For example, Congo peripatus of Western Africa, Neo peripatus of West Indies, Eo peripatus of Malayan archipelago, Capo peripatus of South Africa, then Austro peripatus of Australia, then Chilio peripatus of South America, Tiflo peripatus of India at the foot of Himalayas. So all these are subgenera under the genus Peripatus, and so it shows such a wide distribution. Okay, and you can see another thing is like here the yellow spots represent the fossils, and you can see the fossils had been obtained from North America, from Europe part, from what do you call the Himalayan region. So it has been distributed throughout, isn't it? Here also you can see the Central America region. So all these parts had the fossils plus the present the living forms. It is found in all these regions, isn't it? So it had a wider distribution in the past. Okay. Now coming to the next species, which shows a group which shows the discontinuous distribution, that is the Camelidae. Okay, the camel family. You can see today the Camelidae are represented by the camel yeah, in North Africa and the Asia. Okay, these are actually camel itself. Okay, you can see the dromedary camel as well as the Bactrian camel. Okay, and in South America, it is represented by the llamas. Okay, all these three comes under the same family, Camelidae. And here you can see these two groups, that is the actual camel and the llamas. They are fundamentally similar but differ in detail. The distribution of their fossils shows that the evolution of camels started in the here you can see. Okay, it's these arrows shows the movement. Okay, so the evolution of camels started in North America over here. Okay, the original ancestors of the camel family, and from here they started migrating to Asia across the here this is the Bering Strait. Okay, so it started moving like to Asia through the Bering Strait, from the here across the shallow Bering Strait, and from there it moved to from Asia it moved to Africa. Okay, and you can see from Africa it is believed to have moved to South America through this Isthmus of Panama, and but once they reached these places they became isolated from each other because of different types of factors and barriers. These groups, these populations, once it reached Asia and after reaching Africa and all, they started separating. Okay, they didn't have any connections. Okay, for example, these various factors, it could be because of different types of barriers itself. For example, the Isthmus of Panama, it is thought to have isolated the South American forms from the uh, like uh, and the Mediterranean Sea would have isolated the African fauna. So the African fauna and the South American fauna got isolated because of the submergence of Isthmus of Panama. And once isolated, they started evolving along their own lines. Okay, giving modern camels found in Asia, Africa, and the llamas in South America. But the fossil record of other animals such as tapirs and horses also have the similar kind of evolution, the ancestral location, the migration, and the evolution. Okay, so I hope it is clear. Here also you can see that these had the same ancestor, a common ancestor, but later, because of certain barriers and because of isolation by way of various factors, these got evolved into the modern day members of the camelidae. Okay, you have the dromedary camel, Bactrian camel, and llamas of the present day. Okay, there have been many other kinds of camels in the past, but it got extinct because of certain reasons. Fine. So this is with regard to the discontinuous distribution. Okay. So I hope it is clear. Fine. Okay. So the next we have two more distributions, which but we will be learning it in the next presentation. Okay. Thank you.